The Yellowstone supervolcano, it's a caldera volcano. Like they didn't realize that it was so big until somewhere in like the 2000s, I think it was. They did satellite imagery and they realized, oh my God, that's the caldera of a volcano, like this Yellowstone thing.
It started with a whisper, small, almost unnoticeable. But beneath Mount St. Helens, the earth was restless.
Mount St. Helens has seen an increase in earthquake activity with nearly 350 quakes over the last several months.
Now, scientists are saying this is part of the volcano's recharging process.
Chapter 1. The Awakening. What began as faint tremors beneath Mount St. Helens quickly evolved into a relentless series of quakes. Between January and March, over 400 earthquakes rattled the region, most of them clustered along the volcano's northern slope, the very same area that infamously collapsed in 1980, unleashing one of the most destructive volcanic eruptions in U.S. history. But this time, it's not just the ground that's stirring. Satellite images have captured something equally alarming. The mountain's surface is swelling, an unmistakable bulge, growing ever so steadily. The last time we saw this, the aftermath was catastrophic. And the warning signs don't stop there. Volcanic gas readings are off the charts. Sulfur dioxide levels, often a telltale sign of magma approaching the surface, have more than tripled. Carbon dioxide and hydrogen sulfide are also rising, all pointing to one conclusion. Magma is on the move. But the mountain isn't the only thing that's behaving strangely. Local wildlife seems to sense the danger before we can measure it. Birds have vanished. Elk herds are migrating away from the area. Even small mammals appear lost and disoriented. Nature is sending a signal. Are we paying attention? And then there's the sound. A low, constant hum. Locals describe it as the distant growl of an engine, deep beneath the earth. Scientists at the Cascades Volcano Observatory confirm these are harmonic tremors, a phenomenon linked to magma pushing its way through the crust. All signs are pointing in the same direction. But could this be more than just another isolated eruption? Chapter 2. Yellowstone joins the conversation. When Mount St. Helens shows signs of unrest, the scientific community always pays attention. But this time, eyes are turning to another giant. Yellowstone. Hidden beneath Yellowstone's stunning landscapes is one of Earth's largest and most dangerous supervolcanoes, a sleeping behemoth capable of changing the face of the planet. And now, after Mount St. Helens's seismic activity began ramping up, Yellowstone is showing curious signs of its own. Rising geothermal heat near the Norris Geyser Basin, an uptick in eruptions from Steamboat Geyser, the world's tallest active geyser, GPS data revealing subtle ground uplift across the caldera, and seismic instruments detecting long-period earthquakes beneath Yellowstone Lake. All signs that magma might be shifting deep below. Could these two giants, separated by hundreds of miles, actually be linked? Some geologists believe so. They're revisiting the theory of cascading eruptions, the idea that when one volcano stirs, the ripple effects could trigger another, not through direct lava flow, but by redistributing stress across the Earth's crust. Could Mount St. Helens activity be nudging Yellowstone closer to an awakening? Chapter 3. The Cascade Effect. A chain reaction? It sounds like science fiction. One volcano's eruption triggering another, miles away. But recent research is turning that theory into a credible concern. The Earth's crust isn't a solid block. It's a complex, flexible web of plates and fractures. When a volcano releases pressure, it can subtly shift stress across that network, activating nearby fault lines or disturbing other magma systems. Historical examples support this. After the eruption of Mount Pinatubo in 1991, several volcanoes in the region displayed unusual seismic activity. In Iceland, volcanic eruptions have even prompted activity in neighboring systems. So, what if this isn't just coincidence? What if Mount St. Helens is the first domino in a chain reaction? Could the stress transfer already be pushing Yellowstone toward an eruption? Chapter 4. Watching the Giants. How we monitor volcanoes. Today, scientists have more tools than ever to monitor these geological giants. From arrays of sensitive seismometers that detect even the faintest quake, to gas sensors that sniff out changing chemical signatures, to satellite imaging that tracks ground deformation. Every signal is recorded, analyzed, and compared to past data. This technology allows scientists to piece together the complex puzzle of volcanic activity in real time. But even with all this data, nature keeps its secrets well hidden. A spike in gas, a rumble underground, a bulge on the surface, each could mean disaster, or simply another quirk of Earth's ever-changing geology. It's not about predicting the future perfectly. It's about listening closely enough to catch the warning signs before it's too late. Chapter 5. If Yellowstone blows. The unthinkable scenario. So what if Yellowstone does erupt? A full-scale super-eruption would be apocalyptic. Entire towns would be erased in moments, buried beneath pyroclastic flows and rivers of molten rock. A massive ash cloud would blacken the skies, reflecting sunlight away and plunging global temperatures into what scientists call a volcanic winter. The result? Widespread crop failures, famine, and a long-lasting economic meltdown. Ecosystems would be thrown into chaos, and life as we know it would face unprecedented challenges. Even a smaller eruption could still cripple the region, grounding flights, choking water supplies with ash, and halting transportation and agriculture for months. But while the scenario is terrifying, the odds are slim. Scientists stress preparation, not panic. Chapter 6. Science over fear. Reading the data right. The truth is, Yellowstone's magma chamber is only partially molten. The chances of a super-eruption happening in our lifetime are incredibly low. Thanks to advanced seismic monitoring, gas analysis, satellite imaging, and computer modeling, scientists have built one of the most sophisticated volcano surveillance systems in the world. They're watching every minor twitch and tremble. Emergency protocols are in place. Communities are informed. The world is better prepared now than it's ever been. And while the thought of an eruption can spark fear, the facts and the science offer us reassurance. Chapter 7. Earth's Quiet Warnings. In the end, this isn't just about Mount St. Helens or Yellowstone. It's about understanding the Earth itself, a living, breathing planet that's constantly shifting beneath our feet. Every quake, every puff of gas, every bulge in the rock is part of a grand and ancient conversation. The question is, are we listening? And will we be ready when the Earth speaks a little louder? Thanks for watching. If you enjoyed this journey into Earth's hidden frontiers, make sure to like, share, and subscribe for more fascinating stories from our dynamic planet. And tell us in the comments, do you think these volcanoes could really be connected? Which fact surprised you the most?